Good day, everyone. Today, we are going to discuss computing the quartile of grouped data. Our objective: calculate the specific measures of position, quartiles. Measures of position are also called relative standing. It indicates how an item compares with the other item in a given collection or data set. They measure the data values' relative position within the data set. These measures include the different fractals, percentiles, deciles, and quartiles. Let us remember how to organize data using the frequency distribution table. Frequency distribution table, it is the arrangement of data in tabular form. It has the following information depending on the purpose. Number 1, we have the class limits. Class limits is the smallest or lower class limits and largest upper class limit values that can fall in a given class interval. Second, class boundary. It is the number used to separate classes. The size of the gap between classes is the difference between the upper class limit of one class and the lower class limit of the next class. Third, we have the class frequency. It is the number of observations falling in a particular class. Fourth, we have class width. It is the numerical difference between the upper and lower class boundaries. And fifth, we have class mark. It is the midpoint between the upper and lower class boundaries. Let us consider the scores of 120 grade 10 students in the third quarter math examination. Determine the first quartile. Now, here are the table. We have score and frequency. The set of scores are 51 to 60, 41 to 50, 31 to 40, 21 to 30, 11 to 20, 1 to 10. And the frequency are 7, 21, 49, 21, 18, and 4. Now, how are we going to compute the quartile for group data? We approximate the kth quartile from a frequency distribution table by the formula Q sub k is equal to LB plus the quantity of NK over 100 minus less than CF times I over FQK. Take note of the following. LB means the lower class boundary of the quartile class. I is the class size. N is the total number of observations or scores. K, it is the percentile of interest. CF, less than CF, it is the less than cumulative frequency before the quartile class. And then FQA, that is the frequency of the quartile class. Again, we are going to determine the first quartile. For step 1, before we determine the quartile, complete first the frequency table. And then second, determine the lower class boundaries. Look at the highlighted score. So 51, 41, 31, 21, 11, and 1. These are the lower class limits of each class. Now you are going to subtract 0.5 from each lower limit to get the lower class boundaries. So we have 1 minus 0.5 is equal to 0.5. And then next, 11 minus 0.5 will give you 10.5. Then 21 minus 0.5 is equal to 20.5. 31 minus 0.5 is equal to 30.5. And 41 minus 0.5 is equal to 40.5. And 51 minus 0.5 is equal to 50.5. So these are the lower boundary. We are going to determine the cumulative frequency. Now, how are you going to get the cumulative frequency? Take note, the cumulative frequency is calculated by adding each frequency from a frequency distribution table to the sum of its predecessors. Start adding from the frequency of the lowest score. So our lowest score is 1 to 10. And then our frequency for 1 to 10 is equal to 4. So we are going to begin with 4. Then we are going to add 4 plus 18. We have 22. 22 plus 21. We have 43. 43 plus 49. We have 92. And 92 plus 21. We have 113. And 113 plus 7. We have 120. Now, these are the less than cumulative frequency. Now, after completing the table, you can now compute the quartile class using NK over 4. So, NK over 4, it is getting the position of the given score. For our N, we need to add all the number of frequencies. So, 7 plus 21 plus 49 plus 21 plus 18 plus 4 is equal to 120. 120, and our K is 1 because we are going to find the first quartile. Then solve. 120 times 1, it is 120 divided by 4, that is 30. Meaning to say, you are going to get the quartile class in the 30th position. Now, you are going to compare this to the values in the less than cumulative frequency. So, everybody, eyes on the less than cumulative frequency. Now, the quartile class is the class interval where less than cumulative frequency is greater than or equal to the quartile class. Now, again, our quartile class is 30. Now, if you are going to look at the cumulative frequency, 43 is greater than 30 for the first time. So, hence, we get this interval as our quartile class. Now, we are going to mark 43, 20.5, 21, and 21 to 30 as our given. Next, for step number 5, we're going to obtain the following from our table. So, we have LB, I, and K less than CF or frequency of quartile class. By looking at the table, look at the highlighted numbers. So, for the lower boundary, we have 20.5. For our I, we have 10. So, why is it 10? So, yun yung class interval natin. Kumbaga, 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60. Or, you may just subtract 11 minus 1 equals 10. 21 minus 11 equals 10. 31 minus 21 equals 10. 41 minus 31 equals 10. And 51 minus 41 is equal to 10. Same with 60 minus 50 equals 10. 50 minus 40 equals 10. 30 minus 20 equals 10. And 20 minus 10 equals 10. Now, for our N is equal to 120. Our K is 1. Because we are going to find the first quartile. And then for our less than cumulative frequency, of course, nasa baba ng 43. Since our cumulative frequency is 43, so less than 43 is 22. So you're going to write less than cumulative frequency as 22. Our frequency of the quartile class is equal to 21. Lower boundary equals 20.5 plus interval 10. Number of observation 120. K is equal to 1, less than CF is equal to 22, and frequency of quartile class is equal to 21. Then we are going to solve by substituting the values in the formula. For quartile 1, we have LB plus I times the quantity of NK over 4 minus less than CF all over the frequency of quartile class. For our lower boundary, we have 20.5. For our I, we have 10. For our N, we have 120. K equals 1. Less than CF equals 22. And our frequency of quartile class is equal to 21. Now, let us solve first the number inside the parentheses. So, 120 times 1 equals 120 divided by 4 equals 30. Then, 30 minus 22 equals 8. Then, 8 times 10, we have 80 divided by 21 equals 3.81. Then, 20.5 plus 3.81, we have 24.31. Therefore, the first quartile is 24.31. 25% of all the data points are below or less than 24.31. To find the quartile value of group data, we have to memorize the formula. Q sub K is equal to LB plus I times the quantity of NK over 4 minus less than CF divided by FQK. To properly organize the data in tabular form, it is important to know the values of LB, I, N, K less than CF, and FQK. Of course, you can only obtain that by knowing the quartile class, which is NK over 4. So, I hope you have learned something about quartile of group data. For my next video, try to view decile value of group data. Thank you for watching!